Alright, example 12. Find the limit. The limit of sine of x over x as x approaches infinity. This problem is different from this problem. Sine of x all over x as x approaches 0. We know this is equal to 1, right? And we were able to prove that by going through the proof of the squeeze theorem. This is also a squeeze theorem proof, and this one you will have to prove on the next test. Okay? So, let's take sine of x. We know that sine of x is somewhere between -1 and 1, right? If we drew the graph of sine of x, it would look something like this. Oops, screwed that up. It would look something like this, right? This is basically one cycle where it's going to be between -1 and 1. Your answers, right? So that's why I'm writing this. That sine of x is between -1 and 1. This sine of x is being squeezed between -1 and 1. So this would be the proper setup to use the squeeze theorem. Then I can do this. I can divide each of these by x. Okay? So now, notice that this sine of x over x, that's this function, right? Okay? So now I'm going to use the squeeze theorem. The squeeze theorem states if the limit of -1 over x, that's this function here, as x goes to infinity, if that equals 0, okay, let's talk about why that would equal 0. If you have -1, if you think about infinity, that's a number that just keeps increasing without bound, right? If you divided that by 100, you would get -1/100ths, right? If you divide that by 1,000, you would get -1,000ths. If you divide that by 10,000, you would get -10,000ths. So you can see that this number is getting smaller and smaller and smaller. Eventually, as x goes to infinity, that's going to get closer and closer to 0. Okay, so this is why this limit is equal to 0. And if we have the limit of this function, 1 over x, as x approaches infinity, that's also going to equal 0, this same kind of reasoning here. Then, the conclusion of our squeeze theorem states the limit of sine of x all over x as x goes to infinity must be equal to 0. That's my answer.